Okay, so now I want to talk about the retina. Like, this is the location of the photoreceptive cells. They're located here at the very back of the eyeball, right? In a layered set of cells. This is the retina back here. And what's interesting about the photoreceptors actually is that they are the cells at the very farthest back point of the retina. So you're going to have the light's going to be coming, in through the pupil, passing through the lens, passing through the vitreous humor behind, right? And then being sort of, focused onto, various portions of the retina. But the photoreceptive cells that are going to actually absorb that light energy and convert it into some kind of neuronal response are actually behind several layers of cells. So light actually has to pass through, several layers of cells. In fact, you actually have a place here on your retina, however. It's a little hard to see, but there's a spot here where the cells that are in front of those photoreceptors kind of stretch away this way. So there's more direct light input to the photoreceptors. This sort of pit region is actually called the fovea. And the fovea, we're going to see, has some very specific sort of structural features. There are a lot of very, very tightly packed, photoreceptive cells there. It's where you will see you have the best resolution, the best pixelation in terms of your ability to detect visual input compared to the regions, that are off to the periphery. So let's look at these 5 cell types in the retina. So what we're seeing here is on this side is the retina sort of blown up, and this is the direction of the light input. It would be coming like this, right? The light's coming through here. So the photoreceptive cells are way back here at the back here again, except remember at the foveal sort of pit where there's a little bit more direct access, to those photoreceptors. But at this upper portion here, you've got what's called the ganglion cell layer. These are called ganglion cells, and these ganglion cells are going to have axons that are going to extend out and leave the eyeball. In fact, they're going to carry the visual information, away from the eye and back towards the brain. Now, you should see here on this representation of the eyeball here, there's a spot right here where you see a whole bunch of vessels coming in. For example, that's to help to feed the cells of the retina and of the eye. And also, this is where the ganglion cell axons are going to leave and head back towards the rest of the central nervous system, right? So this layer down here, this is the farthest back. It's interesting to sort of consider why. It turns out that these photoreceptor cells are towards the very back of the retina, partly because they're very energy intensive. They use a lot of nutrients. I mean, we'll see that actually they're kind of a little paradoxical in that they fire most extensively when your eyes are closed, but they fire all the time when your eyes are closed. At night, for example, and so they need to be close to the blood supply. So the blood vessels at the back of the eye are going to be down here. Now the photoreceptors are going to receive the light information, so the light's going to come through these various layers, strike the very back of these photoreceptors. There's going to be some special machinery back here that'll carry out the stimulus transduction. And then these photoreceptors are going to send that information to a layer of cells that we call bipolar cells that are located right here. These have 2 poles, one sort of a receptive pole, sort of a functional dendrite, right? And they have functionally an axon, a second pole going this direction and making synaptic contact with the ganglion cells. And then the ganglion cells are going to collect all their axons, and then they're going to send those ganglion cell axons back out of the eye here. This point where they leave actually there's no place for any photoreceptive cells, right? Because you just have a big cable of ganglion cell axons leaving and heading to the brain, heading in what's called the optic nerve, right? Well, because there are no photoreceptor cells at this particular spot, this is referred to as your blind spot. So if any kind of light information were to strike this region, you wouldn't be able to transduce it because you don't have any photoreceptive machinery there. There are no specialized cells that can carry out stimulus transduction. 2 other layers I want to mention here, or 2 other sort of cells I want to mention here, where the bipolar cells and the ganglion cells sort of synapse, right? You find these cells that are called amacrine cells, and they send their processes to form sort of complicated synaptic connections with multiple bipolar cells, perhaps, and multiple ganglion cells. So they're doing some sort of preliminary sort of processing of this incoming light information before the ganglion cells send that information back to the brain. And there's another sort of layer that's kind of similar down here between where the photoreceptors and the bipolar cells meet. So there's some complicated, synaptic kind of networking going on in the retina itself before output from the eye, leaves at this blind spot, right? As the optic nerve ganglion cell axons, leave the eye and head back towards the rest of the brain.